14 is solving logarithmic equations. We will begin with the opening exercise. It says to convert the following logarithmic equations to equivalent exponential equations. So to do that, we are going to, let's see, are we writing? There we go. We're going to take our little exponent, our little base at the bottom, right here. This is all a base 10 right here. And what we'll do is we're going to scoop it up, move this 10, scoop up this 4, and so we end up with 10 to the 4th power. It's going to equal 10,000. Same thing here, we have an exponent of a 10, so we scoop up that 1/2. So we say 10 to the 1/2 power is equal to the square root of 10. We scoop up this 8, so you have 2 to the 8th power is equal to 256. This 4 is going to scoop up this 4, so 4 to the 4th power is 256. Here, this is an e because we're a natural log. So e to the 0 power is equal to 1. And then this here again is a 10. So 10 to the 3rd power is equal to x plus 2. In examples 1, 2, and 3, they say write each of the following equations as an equivalent exponential equation and then solve for x. So we'll start with number 1, where we take this 10 and we'll do just like we just modeled in the open exercise. We're going to scoop it up, and so we're going to say 10 to the 0 power is equal to 3x plus 7. So 10 to the 0 power, anything to the 0 power, is 1, so 1 equals 3x plus 7. We'll minus 7 to the other side, so 1 minus 7 would give us negative 6 equals 3x, and then we divide by 3 to the other side, and x will equal negative 2. If we did the same thing with number 2, right, we'd start by taking this 2, we scoop up the 4, so we would have 2 to the 4th power is equal to x plus 5. So then if we simplify 2 to the 4th power, we would end up with 16. So 16 equals x plus 5, and then we minus 5 on both sides, and so then x will equal 11. In number 3, this is a plus sign, so if we combine this as a single log, this would become log of x plus 2 times x plus 5, and that would equal 1. So now if we did our scoop with our base, and we scoop this up, you're going to get 10 to the 1st power is going to equal x plus 2 times x plus 5. And so we'll end up multiplying this together. So x times x is x squared. 5x plus 2x is 7x. And then 2 times 5 is 10. This is equal to 10. So if we subtract this over here, the 10's cancel out, so we end up with 0 equals x squared plus 7x. We have a greatest common factor that we can factor out of an x. That leaves us with an x plus 7. And so when we separate this, we find out that x equals 0 and x equals negative 7. You do have to check these for extraneous solutions. So if we plug them in one at a time, if we did, let's say, if we did for x equals 0, that means we would have log 0 plus 2 is 2, so it's log 2, plus log of 0 plus 5 is 5. We want to know, does that equal 1, yes or no? You can use your calculator for that, log 2 plus log 5. And we do, in fact, get a 1. So that one checks out. And so if we try the other one, that would be for x equals negative 7. We would do log, let's see, negative 7 plus 2 is negative 5. And then negative 7 plus 5 is negative 2. We want to know, does that equal 1? And again, you could try that in your calculator and see what happens. You might find it interesting. Plus the log of negative 2. And it turns out that it is a non-real answer. We cannot do that. So therefore, this one is extraneous. So the only one that ends up being a solution that is viable here is x equals 0. And we have to ignore this one right here. So in exercise number 1, it says that Drew said that the equation log base 2 of x plus 1 to the 4th power equals 8 cannot be solved, because what he tried to do, he expanded x plus 1 to the 4th power and multiplied it till he got this, and then realized he couldn't solve that. He was stuck. So therefore, he thinks there's no solution. Is he correct? And demonstrate how you know. So is he correct? No, he is not correct. So he doesn't understand how to take advantage of logarithms. So if we write log base 2 with an x plus 1 to the 4th power equals 8, if we use our log properties, we can actually solve this equation. So the first thing we'll do is we'll actually take this 4 right here in the exponent position and move it to the front. So now we have 4 times log base 2 of x plus 1 equals 8. We could undo multiplication by dividing, so we'll divide both sides by 4. So now we're going to get log base 2 of x plus 1, and 8 divided by 4 is 2. So now we're going to do our scoop. We're going to scoop this up. So 2 squared is 4. So you get 4 equals x plus 1. And we minus 1 to the other side. And so we find out that x is equal to 3. And again, it could always be checked to see if it works out. So we could go to our calculator if we wanted to and check that. But it turns out that when we do plug it in, it does work. And so this is, in fact, a solution. So in these exercises, they want us to solve each one for x. So we take a look at these. We'll start with number 2. We're going to move this 5 right here to the outside. So we rewrite number 2 as 5 times the natural log of 4x equals 15. So then we're going to divide by 5 to the other side. So left over on the left-hand side is the natural log of 4x. 15 divided by 5 is 3. Now remember, the base on a natural log is in e, so when we do our little scoop, we're going to scoop in e. So you're going to get e to the 3rd power is equal to 4x. And if we're going to solve for x, we're going to divide by 4. So e to the 3rd power divided by 4 will equal x. I'm going to leave it at that as opposed to putting that in the calculator. Same thing here for number 3. Right, we're going to take this 2 and we're going to move it out front. So I'm going to have 2 times the log of 2x plus 5, and that's going to equal 4. So this times 2, the undo multiplication, we divide. So when I divide to this side, I get a 2. So my next line is going to say log of 2x plus 5, and again 4 divided by 2 is 2. The base on this log is a 10, so we're going to scoop it up. So 10 squared is 100, so you get 100 equals 2x plus 5. We can minus 5 to the other side, so you get 95 equals 2x. And we divide by 2, and so you get 95 over 2. When we look at number 4, same idea. We want to take this 19 exponent here, we're going to move it to the front. So that gives us 19 times the log base 2 of 5x plus 7. That's going to equal 57. We're going to divide 19 to the other side. And when we divide 19 to the other side, we end up with log base 2 of 5x plus 7 equals 3. So we'll scoop this over. 2 to the third is 8, so 8 equals 5x plus 7. We minus 7 to the other side, you get 1 equals 5x. So x is going to equal 1 divided by 5, or 1/5. In example number 4, we have a subtraction of two logs that we're going to bring together. So when we do that, subtraction is synonymous with division, so if we want to combine our logs, we're going to write one log, and then we're going to put x plus 10 in the numerator, x minus 1 in the denominator, and set it equal to 2. So my base here is a 10, so we're going to scoop this over. So 10 squared is 100, so now you get 100 equals x plus 10 over x minus 1. To undo division, I have to multiply on both sides. So I'm going to multiply 100 by x minus 1 and set that equal to x plus 10. So now I do the distributive property and I get 100x minus 100. That's going to equal x plus 10. I can minus this x over here, so 100 minus 1 is 99x. And if I, at the same time, add 100 to this side, that will equal 110. So if we divide, x is going to equal 110 divided by 99, which is going to reduce itself to 10 over 9. Same thing with example number 5, but this time we see an addition sign. So we write log base 2, and we're going to end up multiplying these two together. Now, it turns out this is a difference of squares. So if we multiply our difference of squares together, we're going to end up with x squared minus 1 equals 3. We're going to scoop this over. So 2 to the third power is 8. We set that equal to this. So it's equal to x squared minus 1. We can minus 8 on both sides. So now we get 0 equals x squared minus 9, which is a new difference of squares. And we can factor that into x minus 3, and then x plus 3, so our potential answers are x equals 3, and x equals negative 3. After you check them for extraneous solutions, they did say check for extraneous solutions, it turns out that 3 is valid, negative 3 is not valid in that design. Alright, so that leaves us with these exercises, numbers 5 through 9, where we'll model each one and show how they are solved as a single piece. So we have a minus sign right here, so that means we're going to, when we combine our logs, we're going to have division. So we'll write 1 log, and then we'll put x squared plus 7x plus 12 over x plus 4, and that's going to equal 0. My base is a 10, so I scoop this over. 10 to the 0 power is 1, and that's equal to x squared plus 7x plus 12 over x plus 4. So I'm going to multiply x plus 4 on both sides, so I can bring the x plus 4 over here. That's going to equal x squared plus 7x plus 12. I'm going to move everything by subtracting to this side. So I'm going to get x squared. When I minus this x over here, 7x minus x is 6x. And I minus 4, I'm going to get 12 minus 4 is 8. Now that's set equal to 0. And then I can factor. So I get x and x. This will end up being a plus 4 and a plus 4 to plus, oh yeah, plus 4 and plus 2. So that means my x is equal to negative 4 and negative 2. If you check them for extraneous solutions, this one ends up not working, and then this one here works. In number 6, again, we have a plus sign, so we write log base 2. 3x times 4 is 12x. We set that equal to 4. And let's see, after that point, we can take and scoop this over. So 2 to the 4th power is 16. So 16 equals 12x. You can divide both sides by 12. And so x is equal to 16 over 12. And if you divide 4 into both of those, that reduces to 4/3. If you do check it, 4/3 is valid, so it is a legit solution. Number 7. So when we take a look at number 7, the first thing that we would probably do in this case would be to move this 2 back into here. So by doing that, we end up with the natural log of x plus 2 squared. So again, we took this number in front and put it back into the log as such. Now we're going to combine. So let's move this over. Oops. Nope, that didn't work. Okay. So anyway, now with the subtraction sign, we're going to combine our natural logs. So we have a natural log with an x plus 2 squared in the numerator and a negative x in the denominator, and we set that equal to 0. So now we scoop our e over. E to the 0 power, anything to the 0 power is 1. That's going to equal x plus 2 times x plus 2, just to make that note, over negative x. We can multiply negative x on both sides, so you get negative x equals, and if we multiply our numerator at the same time, you get x squared plus 4x plus 4. You add x to the other side, so you get x squared plus 5x plus 4. We factor, and you get x plus 4 and x plus 1 And so x is equal to -4, and x is equal to -1. When you check them, it turns out that the -4 is extraneous, but the -1 does work. So the only solution for that is -1. If we look at number 8, in number 8, in this design, what we'll probably choose to do is move this log to the other side. So when we rewrite number 8, it's going to say log x, and when I add this log x right here to the other side, so that way all my logs are together, and the 2 is over here on this side. So now, since this is a plus sign, we can multiply the insides. So when we combine, you get a single log with an x squared equals 2. Our base is a 10, so we scoop it up. And so 10 squared is 100. So you get x squared equals 100. And the square root of 100 is x equals 10. Let's see, last one, number 9. We have natural logs on the left and the right. We're going to bring some together. So when I rewrite number 9, I'm going to keep the ln of x plus 2 on the left. I'm going to add this one to the left. So I'm going to get plus the natural log of x plus 3. And that's going to be equal to the natural log of 12. So since it's a plus sign, when we combine our natural logs, we'll be multiplying x plus 2 with x plus 3. We'll do that in a minute. That's going to equal the natural log of 12. Now, because we have a single natural log on both sides, these actually cancel on both sides. So the only parts I'm interested in is the x plus 2, the x plus 3, and we're going to set that directly equal to 12. So in this case, I multiply x squared. 3x plus 2x is 5x. 2 times 3 is 6. And I set that equal to 12. I'm going to minus 12 to the other side. So now I get x squared plus 5x minus 6 equals 0. I'm going to factor. And so we're going to get an x minus 1 and an x plus 6. So that means x is going to equal 1 and x is going to equal -6. And the only one that ends up being a valid solution is this one. This one does not check out. All right, so that wraps up lesson 14.